Okay, video 5b. I hope you've done question 2 yourself, but I'd just like to do it quickly to point a couple of things out. So y dash equals y minus 1. Well, let's do a bit of calculation. So if I've got y equals 3, then y minus 1 is 2. And then if I move across to here, the x value is irrelevant, isn't it? I've still got y dash equals y minus 1. So this is what happens. I hope you noticed that. Okay, so when y equals 2, right? And so basically we have a differential equation that's independent of x, so none of these values matter. And okay. Okay, etc. And when it comes to doing the slope field, well, I'd start with this. So the right, and then our plus and minus 1, so okay, plus and minus 2. I seem to be better at drawing positive gradients than negative ones. Okay, these are very hard to draw something that's between that steepness and vertical, right? So, okay, and right, naturally, so we have this kind of thing, or the equilibrium solution is that. All right, next one. Okay, nice one here. So I calculated the values for you, save you some effort. But the important thing is this is independent of y. Right, this one was independent of x. Right, we've looked at these. This is y dash equals f of y, and this is y dash equals f of x. Okay, so graphing these, right, so we've got all of these are -2. Oh, yeah, all right, I'll just go left to right, I think. No, I'll start with the -1 because that's probably the easiest. Okay, then the -2. And 0.1 is just ever so slightly positive. And 1.2 is sort of close to a bit more than 1, if I can manage that. And then 2.5 is, pretty steep. Okay, and 4.5. And 8, well, you can't tell the difference between 8 and vertical. Okay, so what? Now the thing here is if you draw, remember not to go through. So from here to here is quite a sharp turn, right? So these ones, these differ by a constant, the plus c. All right, that's it for 5b.